Good morning, my dear students. Today we commence a second topic, namely the properties of triangles in trigonometry, and which is a very interesting and important topic, especially these in properties of triangles. Some problems in properties of triangles can be also proved by using AMGM inequalities. Okay. Now in this topic there are so many formulae. All are called standard formulae, and we assume all the standard formulae. Namely, the first formula is sine rule, which is in any triangle ABC with sides small a, small b, small c, and angles capital A, capital B, capital C. The sine rule states that A by sine A is equal to B by sine B is equal to C by sine C. Each is equal to the circumdiameter, namely 2 capital R, and capital R always represents the circumradius of the triangle of a circle. Is not? So next rule is what is called cosine rule. That means in triangle ABC, small a square, that means side square, a square is equal to b square plus c square minus 2ab cos c. And similarly, b square is equal to c square plus a square minus 2ca cos b, and c square is equal to a square plus b square minus 2ab cos c. See, these two are called sine rule and cosine rule. And third formula is what is called projection formula. That means we will give expressions to the sides A, B and C in terms of a side can be expressed in terms of other two sides and angles. So namely, the one is small a is equal to B cos C plus C cos B, and small b is equal to C cos A plus A cos B, and small c is equal to A cos B plus B cos A. Okay, these three are called the formula for the sides, and also are called projection rules. The other formulae are the sine of half of the angles, cosine of half of the angles, and tan of half of the angles. Namely, that is sine A by 2 is equal to square root of s minus b into s minus c by bc. Everything under square root, where s is nothing but half the perimeter. See, in properties of triangles, the standard notation is 2s is equal to sum of the sides, which is perimeter, and delta always represents the area of the triangle, and capital R circumradius, small r in radius, or small r1, small r2, small r3, they always represent the x radii of the triangle. So that is question, sin A by 2, sin B by 2, sin C by 2. Similarly, cos A by 2 is equal to square root of s into s minus A by BC, and similarly cos B by 2 and cos C by 2. Now another one is what is called tangent rule or Napier's analogy. Tangent rule or Napier's analogy. Namely, that is in a triangle ABC, tan of A minus B by 2, tan of A minus B by 2 is equal to a minus small b by small a plus small b into cot C by 2. Small a minus small b and small a plus small b multiplied by, so they will not be exist there. There we will get cot C by 2, the cot C by 2. Similarly, tan B minus C by 2, tan C minus A by 2. This tan B minus C by 2, tan A minus B by 2, tan C minus A by 2, they are called tangent rules or Napier's analogy. And similarly, area of a triangle delta is equal to square root of s into s minus a into s minus b into s minus c, and this formula also is called Hero's formula. That formula is called Hero's formula. So like that, in the problems we always assume the standard formula, and wherever some others are needed, at that context, I will tell you the formula which we are going to use in problem working. Okay? So, now we will come to the actual problems. Right. Problem number 1. In triangle ABC, if 3A is equal to B plus C, then cot B by 2 into cot C by 2 is equal to 1, 1, 2, 2, 3, 3, 4, 4. This is asked in EAPCET 2003 and way back 𝗬𝗧𝗃 entrance examination 1986. Now 𝗬𝗃 is also an IIT institute. It has become, it was included as an IIT institute some 6 to 7 years back. Okay, right. Now the explanation is small b plus c, 3a is equal to b plus c. So b plus c by a is equal to 3. So now you use sign rule. A is equal to 2r sin A, B is equal to 2r sin B, C is equal to 2r sin C. So if you use sign rule, we will have sin B plus sin C by sin A is equal to 3. Now use sin C plus sin D formula. So using sin C plus sin D formula, 2 sin B plus C by 2 into cos B minus C by 2 by 2 sin A by 2 cos A by 2 is equal to 3. And now we know that sin B plus C by 2 is cos A by 2. So that implies cos B minus C by 2 is equal to 3 cos B plus C by 2, or 2 cos B by 2 cos C by 2 is equal to 4 sin B by 2 sin C by 2, because cos B plus C by 2 is cos B by 2 sin B by 2 minus cos B by 2 cos C by 2 minus sin B by 2 sin C by 2. Taking all cosines one side and all sines another side, you will have 2 cos B by 2 cos C by 2, 4 sin B by 2 sin C by 2. So therefore, cot B by 2 cot C by 2 is equal to 2. So the answer is option number 2. Problem number 2. In triangle ABC, if the sides ABC are in the ratio of 4:5:6, that is A:(B:(C) is equal to 4:5:6, then the ratio of the in radius R to that of the circumradius capital R is 9:7, 12:7, 15:7 and 16:7, and this problem is asked in JE 1996. Now come on, because A, B, C are in the ratio of 4:5:6, we can assume A is equal to 4K, B is equal to 5K, 6 is equal to 6K, where K is a constant. So that means small s, that means half the perimeter, is equal to I plus B plus C by 2, which is 15 by, of course we can say that is 15 by 2, and capital R by small r is equal to, you know that ABC by 4 delta, because delta is equal to ABC by 4R. In a triangle, delta is equal to ABC by 4R. So R is equal to ABC by 4 delta. And you know that small r is equal to delta by S. So therefore, capital R by small r is equal to ABC by 4 delta into S by delta, which is ABC into S by 4 delta square. Now substituting ABC values, that is 120 by 120 S by 4S into S minus into S minus into S minus C, that is 120 by K cubed, of course, K cubed by 4 into 7K by 2, 5K by 2, 3K by 2, which is nothing but if you simplify it, you will get answer is 16 by 7. So capital R is to small r, capital R is to small r is 16 by 7. So the ratio is 16:7. Correct answer is option number 4. So third problem. In triangle ABC, if B plus C is to C plus A is to A plus B, where ABC are small a, small b, small c sides, is equal to 11:12:13, then cos A is to cos B is to cos C is equal to 5:7:9, 7:9:13, 9:13:17, and 7:9:25. JEE 1984 this is. So as usual, you take without a constant term, we can take it as that is B plus C is equal to 11, C plus A is equal to 12, and A plus B is equal to 13. Of course, that constant K is there. You need not write. So therefore, 2 into A plus B plus C is equal to 36, which is then, so that S is equal to 9. So A is equal to, you know that A plus B plus C minus of B plus C, that is 18 minus 11, 7. And B is equal to 2S minus C plus A, which is 18 minus 12, 6. C is equal to 2S minus A plus B, which is equal to 5. So therefore, cos A, and you know that cosine formula, cos A is B square plus C square minus A square by 2BC. And if you substitute those the values of A, B, C, you will get cos A is equal to 1 by 5. Similarly, cos B is equal to 19 by 35, and cos C is equal to 5 by 7. So therefore, cos A is to cos B is to cos C is 7:19:25. 7:19:25 means the correct answer is option number 4, problem number 4. In triangle ABC, if cos A by A is equal to cos B by B is equal to cos C by C, then the triangle ABC is 1. Isosceles, 2. Right angled, 3. Equilateral, 4. Scalon. That means none of the above 3. Now you know that A is equal to 2R sin A, B is equal to 2R sin B, C is equal to 2R sin C. So from the hypothesis you will get cos A by sin A is equal to cos B by sin B is equal to cos C by sin C. That means you will get cot A is equal to cot B is equal to cot C. So in triangle cot A is equal to cot B is equal to cot C means that is it's an equilateral triangle, because A is equal to B is equal to C then. So correct option is 3. Next 5. If in triangle ABC sin A by 4 is equal to sin B by 5 is equal to sin C by 6, then cos A plus cos B plus cos C is number 1, 9 by 16, 2, 19 by 16, 3, 23 by 16, 4, 27 by 16. And again we use cos A plus cos B plus cos C you want. So use cosine formula. Cos A is equal to B square plus C square minus A square by 2BC. Now that is B square means 4R square sin square B, and C square means 4R square sin square C, and A square is 4R square sin square A. So therefore, if you substitute those values, you will get half of 25 plus 36 minus 16 by 5 into 6, which is half of 45 by 30. So which is nothing but 3 by 4. So that is cos A is 3 by 4. Similarly, cos B is 9 by 16 and cos C is 1 by 8. So cos A plus cos B plus cos C is equal to 23 by 16. So which is the correct option is option number 3. 6. The radius of the inner circle of a triangle whose sides are 18, 24, 30 is 2, 1, 2, 3, 4, 2, 4, 3, 6 and 4, 9. And you know that in radius small r is equal to delta by S, where delta is the area and S is the semi-perimeter. So here S is equal to A plus B plus C by 2, that means 18 plus 24 plus 30 by 2, which is equal to 36. And you know that delta is Hero's formula, square root of S into S minus A into S minus B into S minus C, that is square root of 36 into 18 is to 12 into 6, which is simply 6 cubed. So R is equal to delta by S, which is 6 cubed by 36 is equal to 6. So the in radius of this triangle is 6. So the correct answer is option number 3. Next, in triangle ABC, if the angles are in the ratio 1:2:3, then the corresponding sides are in the ratios of 1:2:3, 2:3:4 and 1:√2:√3 and 1:√3:2. Now we know that the angles are in the ratio 1:2:3. So if you take the angles A, B is equal to 2A, 3 is equal to 3A. So therefore A plus B plus C is equal to, you will get 180 degrees. So 6K is equal to 180 or K is equal to 30 degrees. So therefore the angles are 30, 60 and 90. Angles are 30, 60 and 90. That is my right angle triangle, that is. So now A is equal to sin 30 degrees, which is equal to half. B is equal to sin B is equal to sin 60 degrees, √3/2. And C is equal to sin 90 is equal to 1. So therefore A is to B is to C is equal to half is to √3/2 is to 1, which is nothing but 1 is to √3 is to 2. So the correct option is option number 4. Next, in triangle ABC, A chord A plus B chord B plus C chord C is equal to 2 times the in radius, 2, 2R plus circumradius, 3, 2 into in radius plus circumradius, and 4, R plus 2 into small r plus twice the circumradius. Now, coming to solution, A chord A plus B chord B plus C chord C is equal to, you know that, right? A is equal to 2R sin A, B is equal to 2R sin B, C is equal to 2R sin C. So then this will be A chord A plus B chord B plus C chord C is equal to 2R into cos A plus cos B plus cos C. That is 2R into cos A plus cos B plus cos C is 1 plus 4 sin A by 2 sin B by 2 sin C by 2. Because that we know, because A plus B plus equal to 180, cos A plus cos B plus cos C is 1 plus 4 sin A by 2 sin B by 2 sin C by 2. Now you take capital R inside, then 2 into capital R plus 4R sin A by 2 sin B by 2 sin C by 2. And in triangle ABC, in radius R, in terms of the angles and circumradius, is small r is equal to 4R sin A by 2 sin B by 2 sin C by 2. So the 2 into capital R plus small r. So the correct option is option number 3. Next, 9. In triangle ABC, let P be the ortho center and AP is equal to X. AP is equal to X, BP is equal to Y and CP is equal to Z. Then X plus Y plus Z is equal to 2 small r, 2 capital R, 2 into capital R plus small r, 4 small r capital R. Now you can take that is in triangle ABC, suppose AD, BE, CF, that is AP, AD, BE, CF are the altitudes meeting at the orthocenter P. And by hypothesis you are given that AP is equal to X, BP is equal to Y, CP is equal to Z. Now X is equal to AP, but AP is 2R cos A. Please remember here, you can go through any book on trigonometry. The distance of the orthocenter from the vertices. Please remember, see carefully, hear it. The distances of the orthocenter of a triangle from the vertices A, B and C are respectively 2 capital R small cos A and 2 capital R cos B and 2 capital R cos C. So here X plus Y plus Z is equal to, if you use that formula, 2 capital R into cos A plus cos B plus cos C, and that is again 2R into 1 plus 4 sin A by 2 sin B by 2 sin C by 2. That is again 2 capital R plus 2 small r, which is equal to 2 into capital R plus small r. So 2 into capital R plus small r means option number 3. Problem number 10. In triangle ABC, 4 capital R small r into cos A by 2 cos B by 2 cos C by 2 is equal to 1 delta, 2 delta, 3 small r plus delta, 4 capital R plus delta. Now 4 capital R cos A by 2 cos B by 2 cos C by 2. Now here you use the half of the angles formula. Cos of half of the angles formula we are using. Cos A by 2, we know that the square root of S into S minus A by BC. So if you use the cosine formula, you will get 4ABC by 4 delta into delta by S into square root of S minus A into S minus B into S minus C into AB. So if you, after simplification, you will get square root of S minus A into S minus B into S minus C into S, which is nothing but delta. So the answer is option number 1. Please remember here what you have used is small r is equal to ABC by 4 delta and small r is equal to delta by S and cos A by 2 square root of S into S minus A by BC. Similarly, cos B by 2 is equal to square root of S into S minus B by CA and cos C by 2 is square root of S into S minus C by AB. So here we have used the formula for capital R, which is ABC by 4 delta, small r, delta by S and half of the cosines of the angles formula. So if you simplify delta, so the correct option is option number 1. Next, so 11th problem. In triangle ABC, if 1 by B plus C plus 1 by C plus A is equal to 3 by A plus B plus C, then angle C is equal to 30 degrees, 2 60 degrees, 3 45 degrees, 4 75 degrees. Generally, these are also very, very standard formula and which are asked in many examinations, competitive examinations as well as intermediate plus 2 stage also. And whenever you will get 1 by B plus C plus 1 by C plus A is equal to 3 by A plus B plus C, then you can always conclude that here C is a common side in the hypothesis. Please see 1 by B plus C plus 1 by C plus A. So you will get angle C. The formula for angle C is nothing but you will get the angle C is always 60 degrees. So what that is, you can remember it. And the converse of this problem is also true. That means in a triangle, angle C is equal to 60 degrees, then 1 by B plus C plus 1 by C plus A will be always equal to 3 by A plus B plus C. So from the hypothesis, you will get A plus B, simplify it. The given hypothesis you simplify. A plus B 2 plus 2C into A plus B plus C is equal to 3 into B plus C, B plus into C plus A. Now the expand, multiply both sides, that is expand it and simplifying the terms. That means cancelling the common terms and simplifying it, you will get A square plus B square minus C square is equal to AB. But AB can be written as, what you will get is or A square plus B square plus C square minus C square by 2AB is equal to 1 by 2. But 1 by 2 means cos 60 degrees. So angle C is equal to angle C is equal to 60 degrees. So correct option is option number 2. Please remember that this is a very standard problem which will be asked in regular examinations and also EAPCET state level EAPCET examinations, and it was asked in JEE also, and of course from 20 to 15 to 20 years back, that is. So here always you can remember that is whatever be the common side, that angle is the 60 degrees. Next, 12. In triangle ABC, if A is equal to 60 and B is equal to 30, then A is to B is to C is equal to 1, 2 is to 1 is to root 3, and 2, 1 is to root 3 is to 2, and 3, root 3 is to 2 is to root 2, and root 4, root 3 is to 1 is to 2. Angle C is equal to 90 degrees. So that means angle C 90 degrees. So small a is to small b is to small c is equal to, and you know that sin A is to sin B is to sin C by sin rule, because A by sin A is equal to B by sin B is equal to C by sin C. Each is equal to 2 capital R. So this shows that sin A means sin 60 root 3 by 2, sin B means half, and sin C means 1. So the ratio is root 3 is to 1 is to 2. So which is the correct option is root 3 is to 1 is to 2. Correct option is option number 4. 13. In triangle ABC, if A is equal to 13, B is equal to 14, C is equal to 15, then 2 capital R, that means circumdiameter, is equal to 1 65 by 3, 2 65 by 4, 3 64 by 5, and 4, 56 by 4. Now, here you know that 2s is equal to a plus b plus c, which is nothing but 42, or s is equal to 21. Next, so s is equal to 21 and s minus a is equal to 8, s minus b is equal to 7 and s minus c is equal to 6. So, capital R is equal to ABC by 4 delta, which is ABC by 4 into square root of s into s minus a into s minus b into s minus c, or 2r is equal to 65 by r, 65 by 4. So, therefore, of course, by substituting the values of ABC, s minus a, s minus b, s minus c, if we simplify it, then 2 capital R is equal to 65 by 4. The correct option is option number 2. Next, 14. In triangle ABC, 2 into a sin square c by 2 plus c sin square a by 2 is equal to 1 a plus b plus c, 2 b plus c minus a, 3 a plus b minus c, 4 c plus a minus b. So, now 2 into a sin square c by 2 plus c sin square a by 2 can be written as is equal to a into 1 minus cos c plus c into 1 minus cos a. So, that is a plus c minus a cos c plus c cos a. By projection formula, a cos c plus c cos a is small b. So, that is a plus c minus b. So, the correct answer is option number 4. Next, 15. In triangle ABC, if a square, b square, c square are in AP, then cot A, cot B, cot C are in GP, geometric progression, 2 arithmetic progression, 3 harmonic progression, and here all the terms are equal. Cot A is equal to cot B is equal to cot C. So, solution b square by hypothesis, you know that b square minus a square is equal to c square minus b square, because a square, b square, c square are in AP. So, this shows that sin square b minus sin square a is equal to sin square c minus sin square b, because a is equal to 2r sin a, b is equal to 2r sin b, c is equal to 2r sin c. So, which implies that sin b plus a into sin b minus a is equal to sin c plus b into sin c minus b. That is standard formula. You know that in elementary trigonometry, we proved that sin a plus b into sin a minus b is always sin square a minus sin square b. So, but sin b plus a is equal to sin c. Why? Because b plus a is equal to 180 minus c. Sin 180 minus theta is sin theta. So, therefore, you will have sin c into sin b minus a is equal to sin a into sin c minus b. So, this shows that sin a minus b by sin a is equal to sin b minus c by sin c, because multiplying both sides minus sin b minus a becomes sin a minus b, sin c minus b becomes sin b minus c. So, this shows that if we simplify it, that cot b minus cot a is equal to cot c minus cot b. How you get this one? Right, sin a minus b is sin a cos b minus cos a sin b. Similar, sin b minus c as sin b cos c minus cos b sin c. And if you simplify it, then you will get cot b minus cot a is equal to cot c minus cot b, or what you will get is 2 cot b is equal to cot c plus cot a. So, which is, that means cot a, cot b, cot c are in arithmetic progression. So, the correct option is option number 2. Right. 16th. In triangle ABC, a square sin 2b plus b square sin 2a is equal to 1 2 delta, 2 3 delta, 3 4 delta, 4 6 delta, where delta is the area of the triangle. Now, a square sin 2b plus b square sin 2a is equal to 2a square sin b sin cos b plus 2b square sin a cos a. So, that is equal to 2a into, see, for a sin b, you write b sin a, because a by sin b is equal to b by sin a. It's not b by sin b. A by sin a is equal to b by sin b. So, if you cross multiply it, you look at a sin b is equal to b sin a. So, this a square you write as a into a. So, when you use that formula, that one, you will get that a square sin 2b plus b square sin 2 is equal to 2a into b sin a cos b plus 2b into, similarly, plus 2b into a sin b cos a. That is 2ab into sin a plus b that is 2AB sin C. And you know that half triangle, the delta area is given to be half BC sin A is equal to half CA sin B is equal to half AB sin C. So, using that one, 2AB sin C is equal to 4 delta. So, the correct option is option number 3. Next, 17. In triangle ABC, if tan A minus tan B by tan A plus tan B is equal to C minus B by A, then angle A is equal to 1 30 degrees, 2 45 degrees, 3 60 degrees, 4 5 pi by 12. Right. By hypothesis, tan A minus tan B by tan A plus tan B is equal to C minus B by C. So, if you simplify left hand side, you will get sin A minus B by sin A plus B is equal to sin C minus sin B by sin A. So, that implies that sin A minus B is equal to sin C minus sin B. So, implies sin A minus B minus of sin A plus B is equal to minus sin B. So, you will get that if you after simplification you will get 2 cos A sin B is equal to sin B, or cos A is equal to 1 by 2. So, A is equal to 60 degrees. So, the correct option is option number 3. Next, 18th problem. In triangle ABC, if A square sin 2B plus B square sin 2A, of course, in the not if, just A square sin 2B plus B square sin 2A is equal to 2 delta, 2 3 delta, 4 delta, 6 delta. That means A square sin 2B plus B square sin 2A is equal to 2A square sin B cos B plus 2B square x. Again, writing A sin B is equal to B sin A. So, you will get a 2AB sin A plus B, which is equal to 2AB sin which is equal to 4 delta. I think, sorry, this problem is repeated again. Please don't worry. Of course, rarely a problem will be repeated because we cannot remember each and every problem which we have already discussed. So, sometimes a problem, 1 or 2 problems may be repeated. For that, you need not bother about. So, for 18th problem, the answer is option number 3. In triangle ABC, cot A plus cot B plus cot C is equal to 1 A square plus B square plus C square by 4 delta, 2 A square plus B square plus C square by 2 delta, 3 S by 2 delta, and 4 A square plus B square plus C square by delta. Of course, this is a very standard problem, and also it was it may be worked out in many textbooks. Now, by writing cot A plus cot B plus cot C is equal to cos A by sin A plus cos B by sin B, cos C by sin C, and using cosine rule, cosine formula, that is equal to B square plus C square minus A square by 2BC sin A, C square plus A square minus B square by 2CA sin B, and A square plus B square minus C square by 2AB sin C. So, which is nothing but B square plus C square minus A square by 4 delta, and C square plus A square minus B square by 4 delta, and A square plus B square minus C square by 4 delta, because delta is equal to half BC sin A, half CA sin B, and half AB sin C. So, therefore, the given cot A plus cot B plus cot C is equal to, after simplification, you will get 1 by 4 delta into A square plus B square plus C square. So, the correct option is option number 1. Next, right, 20th. In triangle ABC, sin B plus C by sin B minus C is equal to 1 small b plus C by small b minus sin C, and 2 b square plus C square by b square minus C square, and 3 b square minus C square by A square, and A square by B square minus C square. Now, you can write that is sin B plus C by sin B minus C, multiplying numerator and denominator with sin B plus C, that equal to sin square B plus C by sin B plus C into sin B minus C. So, that is sin square pi minus A, because B plus C is equal to 180 minus A, sin square pi minus A by sin square B minus sin square C, which is sin pi minus A is sin A. So, that is 4 r square sin square A. So, that is multiply both numerator denominator with 4r square. So, 4r square sin square A by 4r square into sin square B minus sin square C. and 4r square sin square is small a square. Small a square by small b square minus small c square. So, the correct option is option number 4, 21. In triangle ABC, if a square, b square, c square are in AP, then cot A, cot B, cot C are in 1. Geometric progression, 2. Arithmetic progression, 3. Harmonic progression, 4. Arithmetico-geometric progression. Now, by hypothesis again, because they are a square, b square, c square are in AP, b square minus a square is equal to c square minus b square. That implies sin square b minus sin square a is equal to sin square c minus sin square b. Again, same simplification. Sin b plus c into sin b minus a is equal to sin c plus b into sin c minus b. So, that is sin c into sin b minus a is equal to sin a into sin c minus b. So, this shows that sin b minus a by sin a is equal to sin c minus b by sin c. So, this will give you that sin a minus b, multiply both sides with sin b, 1 by sin b, multiply both sides with 1 by sin b. So, that is sin a minus b by sin a sin b is equal to sin b minus c by sin b sin c. So, now expand it, sin a minus b. Sin a cos b minus cos a sin b by sin a sin b is equal to sin b cos c minus cos b sin c by sin b sin c, which shows that cot b minus cot a is equal to cot c minus cot b, or 2 cot b is equal to cot c plus cot a. So, that cot a, cot b, cot c are in AP. Option number 2. Next, 22. In triangle ABC, a square sin 2b plus b square sin 2a is equal to, of course, this also, and 1, 2 delta, 2, 3 delta, 3, 4 delta, 4, 6 delta. So, a square sin 2b plus b square sin 2a is equal to 2a square sin b cos b plus 2b square sin a cos a. So, again 2a into b sin a cos b plus 2b into a sin b cos a. So, that is, you will get 2ab into sin a cos b plus cos a sin b, 2ab sin a plus b, that is 2ab sin c, and that is 4 into half ab sin c is equal to 4 delta, because delta is equal to half ab sin c is equal to half bc sin a is equal to half ca sin b. So, the correct option is option number 3. Next, 23. In triangle ABC, a sin b minus c plus b sin c minus a plus c sin a minus b equals is equal to 1 yes, 2 1, 3 0, 4 2. Now, a sin b minus c is equal to 2r sin a into sin b minus c. So, that is 2r sin b plus c into sin b minus c. So, that is 2r into sin square b minus sin square c. So, that is sigma a sin b minus c is 1 by 2r into b square minus c square plus c square minus a square plus a square minus b square, which is equal to 0. So, the answer is, correct option is option number 3, 24. In triangle ABC, cot A plus cot B plus cot C is equal to a square plus b square by 2 delta, a square plus b square plus c square by 4 delta, a plus b plus c by 4 delta, a square plus b square plus c square by delta. Now, cot A plus cot B plus cot C can be written as cos A by sin A plus cos B by sin B plus cos C by sin C. You use cosine rule and sine rule, and substituting cosine rules and using cosine rules and sine rules and simplifying, you will get that is equal to a square plus b square plus c square by 4 delta, and the correct option is option number 2, 25. In triangle ABC, if angle A is equal to 30 degrees and area delta is root 3 by 4a square, then the difference of the angles B and C is 1 75 degrees, 2 60 degrees, 3 90 degrees, and 4 45 degrees. Now, you know that root 3 by 4a square is equal to delta, but delta is equal to half a b sin c. So, that you can write as half a square b sin c by a. That means multiplying numerator denominator with a. That is half a square. B you can write as 2r sin b, and that is so sin b sin c by sin a. So, therefore, what you will get is root 3 by 4, a square will cancel. So, root 3 by 4 is equal to sin b sin c, that means since sin 30 is equal to sin a is equal to half, or 2 sin a is equal to 1. So, root 3 by 2 is equal to cos a which is minus of cos b plus c, which is minus cos b cos c plus root 3 by 4. Cos b cos c is equal to minus root 3 by 4. So 1 and 2 imply cos b minus c is equal to cos b cos c plus sin b sin c, which is minus 3 by 4 plus root 3 by 4, which is equal to 0. So the difference of the angles mod b minus c is equal to 90 degrees. 26. In triangle ABC, sigma a cubed sin b minus c equals 1, 0, 2 ABC, 3, 2 ABC, 3, 4 ABC. This is an important problem. Even though a little bit lengthy in verification, of course, this will not be little bit lengthy, but if you replace sine with cosines, that will be a little bit lengthy. I will tell you. So here a cubed sin b minus c you take. A cubed sin b minus c you can write as a square into a sin b minus c. 1a you write as 2r sin a. And a replace with 180 minus b plus c, that means b plus you will get. So a cubed sin b minus c is equal to a square into r into sin b plus c into sin b minus c. Okay. So that is r a square into sin square b minus sin square c. That is equal to r a square into sin square b minus sin square c, b square minus c square by 4r square. So a cubed sin b minus sigma a cubed sin b minus is equal to 1 by 4r into sigma a square into b square minus c square, and that is, you know that it equal to 0. So here what you have to do, you simplify first a cubed sin b minus a. For a cubed sin b minus a, what you did is, for 1a we have replaced by 2r sin a and sin a we have replaced by sin b plus c. Okay. So if you simplify it, you will get a cubed sin b minus c is r capital R into a square into b square minus c square by 4r square. Okay. That r will cancel, 1 by 4r you will get common. So the sigma a cubed sin b minus is 1 by 4r into sigma a square into b square minus c square, but that is 0. Because sigma a square minus b square, a square into b square minus c square is 0. So in triangle ABC, sigma a cubed into sin b minus c is always equal to 0. But whereas sigma a cubed into cos b minus c is 3abc you will get. If you replace sin b minus c with the cos b minus c, you will get 3abc, the answer is. But that requires a little bit simplification. So correct option is 1. Next, in triangle ABC, if a square plus b square plus c square is equal to 8r square, then one of its angles is 45, 60, 30 and 90 degrees. A square plus b square plus c square 8r square implies, write a is equal to 2r sin a, etc. You will get sin square a plus sin square b plus sin square c is equal to 2. So which indicates, but sin square a is 1 minus cos 2a by 2 plus 1 minus cos 2b by 2 plus 1 minus cos 2c by 2. So that indicates that cos 2a plus cos 2b plus cos 2c is equal to minus 1. But in any triangle a plus b plus c is equal to 180, cos 2a plus cos 2b plus cos 2c is minus 4 cos a cos b cos c minus 1, which is equal to minus 1, or cos a cos b cos c is equal to 0. So therefore one of the angles must be a right angle. So in any triangle, if a square plus b square plus c square is 8r square, capital R square, then the triangle must be a right angled triangle. So correct option is option number 4. Next, 28. In triangle ABC, if cos b plus cos c is equal to 2 into 1 minus cos a, then the order, the sides ABC are in AP is, ABC they are ABC are in AP, or BSC or CAB in AP, BC or ACB in AP, or CBR in AP. The order in which the sides are in AP. So cos b plus cos c is equal to 4 sin square a by 2, which implies 2 cos b plus c by 2 into cos b minus c by 2, 4 sin square a by 2. That is sin a by 2 cos b minus c by 2 is equal to 2 sin square a by 2, which gives cos b minus c by 2 is equal to 2 sin a by 2. Or that is 2 cos a by 2 cos b minus c by 2. Multiply both sides with cos a by 2. is equal to 4 cos A by 2 sin A by 2. So that is 2 sin B plus C by 2 into cos B minus C by 2, 2 sin A, and this is nothing but sin B plus sin C. The left hand side is sin B plus sin C is equal to 2 sin A. So therefore B plus small c is equal to 2 small a. That means BAC or CAB, they are in AP. So correct option is option number 2.